Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. I hope you are all doing great and tackling your P3 preparations with confidence and focus. Since I'm using full screen, I have also opened YouTube on my phone so I can read your comments. This is a short lecture of vectors, point to line, shortest distance. An important advice. We should be nice to everyone. Now, how to find point to line shortest distance? The concept is a line L will be given and a point A or B will be given. These two will be given. And the question is find the shortest distance from point B to line L. So make a rough sketch. This is line L, this is point B, and we need this distance, perpendicular distance from B to line L. Let's suppose this point is F, the foot of perpendicular, and its coordinates are x, y, z. Equation of line will be given. R is equal to A plus TQ. And point coordinates of B will be given x1, y1, z1. So two things will be given. Line equation of line L and point B. And the most important part of this question is we need coordinates of F. See, for coordinates of F, we know the coordinates of R, the position vector of R is x, y, z. And the position vector of OF is also x, y, z. So for OF, we can replace R by OF into this equation. So by replacing R by OF, we can get OF in terms of T, scalar multiple T, because this equation in terms of T. So we have got OF, but it is in terms of T. The problem is T. Now for T, we have to find this vector BF. Let me repeat this. Equation of line L and a point B. These two things will be given. This is the line L and this is the point B. And we need this shortest distance from B to line L. I suppose this point as F, foot of perpendicular from B to line L. Right? Now the problem is we don't have F. For F, we should replace R by OF because both have same position vector. R, the position vector of R is XYZ and the position vector of OF is also XYZ. So replace R by OF into this equation. So we have got OF in terms of T. Now understand till here. We have got the first thing, OF. Now the problem is OF is in the form of T. Now find vector BF. This is the second step. This is the first. This is the second. Find vector BF. This is very simple. OF minus OB. This is also in terms of T. Now for the value of T, take the dot product of these two vectors, BF and direction vector of line L. So BF is perpendicular to direction vector of line. So their dot product must be 0. When you will use this, you will get the value of T. Now the next step, substitute T back into BF and get BF vector. Next, get the magnitude of BF. So this is the concept of shortest distance in vectors. First find OF by replacing R by OF into this equation. Then find vector BF. Then find the dot product. Take the dot product of these two vectors and get the value of T. then substitute t back into bf, and finally get magnitude of bf. This concept is mentioned here. Make a rough sketch. Equation of line L is given, point B is given. Suppose this point as f, foot of perpendicular from B to line L. Now replace R by OF into this equation for OF. This is here. Now find vector BF. For T, take the dot product of BF with Q and get the value of T. Now substitute T back into BF, get the vector BF, and then get its magnitude. What if the question is find the position vector OF, find the foot of perpendicular, then substitute T into OF. So there are two types of questions. The first question is find the shortest distance, then substitute T back into BF and then get its magnitude. And if the question is find the position vector of foot of perpendicular, then substitute T into OF. For foot of perpendicular, substitute T into OF. For shortest distance, substitute T into BF. So check this concept again, then I will explain one question of this kind. Now, a question of this type. Now, this is the question. I'm solving this last part. Find the position vector of P, the foot of perpendicular from D to the line MN. We have the equation of line MN in the previous part, and we have the position, we have the point D. OD. OD is this. This is OD. 0, 0, 1. So let me copy this equation first. So this is R. Now make a rough sketch. This is Q, the direction vector of the line. This is D. Zero, 0, 1, and we need the shortest distance, and it is denoted by P in the question. So X, Y, Z. We need basically position vector P, not shortest distance. So number one, we have to work for P. I told you replace R by foot of perpendicular. So OP vector is 2 minus T, 2T, 1 plus 2T. This is the position vector OP. Now find DP. It's OP minus OD. So OP is 2 minus T, 2T, 1 plus 2T. OD is 0, 0, 1. So the simplified form of this is 2 minus T, 2T, 2T. Now the third step is take the dot product of dp with q, because we need t. This is dp and this is q, and both are perpendicular, so their dot product must be 0. So 2 minus t, 2t, 2t, and this is q. 1 minus 1 2 2. So 2 minus 2 plus t, 4t, 4t, 0. So I think 9t is 2, so t is 2 upon 9. It's 4 upon 9. Let me check this. 2 okay, so 1 plus 2t. Okay, this is 0 0 2. D is 0 0 2. Yes, the coordinates of D are 0 0 2. So this is 2. So this should be 2t minus 1. So minus 2 plus t, 4t, 4t minus 2. Therefore t is 4 upon 9. Now we need OP. So substitute 4 upon 9 into OP. And OP is 2 minus t, 2t, 1 plus 2t. So when you will simplify this, you will get OP. And this was required in this question. We had to find OP. So this is the way to solve questions of shortest distance. What if the question was find the shortest distance? Then substitute t into dp. Get this vector and then find its magnitude. This is the way to get the shortest distance, and this is the way to get the position vector of the foot of perpendicular. You're welcome. Majid Saab's comment. Here is the fair solution. So first replace R by OP. This is OP. Then find DP. DP is OP minus OD. This is DP. Then take its dot product with the direction vector of the line to get the value of t. Then substitute t back into OP because we need OP. What if the question was find shortest distance? Then substitute t into dp and get its magnitude. Let me check one another question of this type. Yeah, this is the shortest distance question. Question number 2C. Shortest distance from origin to line BC. So this is the equation of BC, and we need origin to this line distance. So suppose this point as F, this is origin. Now get OF. So OF means replace R by OF. Now take the dot product of this vector with Q to get the value of t, and then substitute t back into OF and get its magnitude. I just want to check a very good question of this type. You can get the link of this file from math website. This is available on math website. Yeah, this is a very good question. Find the position vector of the foot of perpendicular from A to L. Now equation of L is given, point A is also given. So make a rough sketch. This is A, this is line L. So this is the foot of perpendicular. So replace R by OF. This is OF. See, this is OF. Now get AF. AF is OF minus OA. This is AF. Now take the dot product of AF with Q for the value of lambda. AF dot Q will give you lambda. Now substitute lambda into OF because we had to find OF. This part is also very important. Find the position vector of the reflection of A in L. This is very simple. This is line L. This is point A and its reflection must be here. And the both distances are same. Equidistant. A and A dash are equidistant from line L. So F is the midpoint of A and A dash. Because the reflection of A is A dash. So both distances are same. So F is the midpoint of A and A dash. So you can write A dash is twice of AF. A dash is twice of AF. And A dash will become OA dash according to vectors. This is OA. This is OF minus OA. Just substitute OA, OF, OA here and get the value of OA dash. Just because of lack of time, because paper is on Monday, I couldn't spend more time on vectors. Most of the students were asking to explain shortest distance. That is why I had to take this class in urgency without any notice. So I hope this lecture will help all the students who are watching and who will watch to understand how to find shortest distance in vectors. So if you find my YouTube channel helpful for you and other students, I would be truly grateful if you subscribe and share it with your friends. Good luck and